For today's project, we are going to be aerospace engineers and create our own electric hovercraft. Our hovercraft uses aerodynamic lift to lift it slightly into the air, and it's going to use thrust to push it forward.
Now that we know what we're making, let's make sure that we have all of our materials ready. Inside of your project bag, you should have one of these small 3.2 volt motors, a 9 volt battery, and a 9 volt battery holder, a mini 2-blade propeller, one double-sided square, a 7-inch by 5-inch plastic bag, which could be the bag that the project came in, a 8-inch strip of copper tape, a sheet with your hovercraft template, and outside of your project bag, you should also have tape, scissors, a ruler, and a marker. Once you have all of your materials ready, we can start building our project.
Let's start by making the hovercraft's air cushion. Begin by cutting out ruler A and the rectangle ruler from your hovercraft template. Make sure to cut these out as accurately as possible, since we are going to need to have this as clean and accurate measurements as possible. And after cutting those out, you could set the hovercraft template to the side. Grab your ziplock bag and a marker and flip it over to the side that does not have the Dreams for School zipper. This is going to be the bottom of your air cushion. Grab ruler A, which should be a 1-inch by 1-inch square, and align one of its edges to the shortest side on the ziplock bag. It should be the side that does not have the ziplock mechanism. Next, we're going to center along that edge. This part doesn't have to be too perfect. Just try to make it as centered as possible. Like that. Now, grab your rectangle ruler and center it with ruler A along the 2-inch edge. So the same case, we're going to center it along the edge, trying to make sure that this edge is equal to that edge. Once you are confident with how the rectangle ruler is centered, go ahead and remove ruler A and use your marker to outline the rectangle ruler on the ziplock bag. This is going to be the bottom of your air cushion and will function to expel the air downward and lift our hovercraft. Carefully cut out the rectangle, making sure that you only cut through the layer you drew the rectangle on, not both sides of your ziplock bag. The best way to do this is to open your ziplock mechanism to allow you to fold your ziplock bag in half and making sure that we aren't going to cut outside of the rectangle. We can make a small cut inside of it. Then we can unfold the fold we just made. Carefully insert the scissors into the hole that you just cut out and cut out the outlined rectangle. Again, you want to make sure that you're not cutting through both layers. Make sure to show this part to your students slowly so that they understand well, and reiterate that you should only cut through the layer that you drew the rectangle on. So just to double check, you shouldn't be able to stick your finger all the way through. In the case that your student might have accidentally cut through both layers, you can have them place a small piece of tape on the bottom layer to fix it. Then flip your Ziploc bag over to where the Dreams for Schools sticker is on. The rectangle that you cut out previously should now be on the bottom of your hovercraft. Cut out ruler B from your hovercraft template for this next step. Next, you're going to take your hovercraft template, and if the hole is facing upward, you're going to go ahead and flip your hovercraft bag over so that now the previously cut rectangle is now at the bottom. Next, I'm going to go ahead and peel off the hovercraft sticker. And grab ruler A, which should have been previously cut, and you're going to once again, on the other short edge of your Ziploc bag, where the Ziploc mechanism is, you're going to align it and center it along the Ziploc mechanism, not on this edge. So again, along this Ziploc mechanism, and we're going to center it as best as possible. Then, just as we did with the rectangle ruler, align and center ruler B with ruler A along the 1.75 inch edge. Once you are confident that it is centered, on the opposite end of ruler B that is not touching ruler A, use your marker to draw the 1.75 inch line. In other words, not on this edge, we're going to be drawing our line on this edge. This is going to be the top of your air cushion and will function as your air intake. Once you've ensured that your line is centered, carefully cut it out. So I had to go back and draw a new line since the one that I drew before wasn't very centered. And once again, I used the 1 inch ruler as well as the 1.75 inch ruler to double check my alignments. And just as we did with the bottom square, the best way to do this is to open your Ziploc mechanism again, and what you're going to do is flip or fold it in half again and make the two endpoints of your line. It may be a little hard to see, but if you hold your hand behind the line or a white piece of paper behind it, you'll be able to see it a little better. And what you're going to do is both endpoints of your line, when you fold your Ziploc bag in half, you're going to make those endpoints touch like this. I'm going to flip it so that the line is closer to me. And once you've ensured that you folded it in half correctly, you're going to cut along the line. You should notice that your 1.75 inch line is now halved and it can very easily be cut. And once you have done so, if you unfold the Ziploc bag back to its original position, you should have a straight line. Next, grab your hovercraft template and cut out the whole piece. Then you're going to grab your whole piece and align the inside cutout with the air intake that you just cut out by laying it flat on top of your Ziploc bag. And making sure again that the inside cutout is aligned with the 1.75 inch line that you just cut. You should notice that they are about the same size, if not the same. And once you've ensured that the inside cutout is aligned with your air intake cutout, you can go ahead and grab a piece of tape and tape it down. Do this on the other side. Now we want to ensure that our air intake doesn't rip when the air is entering the air cushion. So we're going to stick another piece of tape right before the holes cut out as shown. Now cut out the lift thrust divider from the template. Then, with the side that has the little tab cut out, insert it into the air intake or your 1.75 inch line. You should notice that they are about the same, so that this little tab cutout could be inserted relatively easy. If you're having trouble, you could also pinch the ziplock bag a little to lift it up. Like so. We're going to need to lift the divider, so cut the air cushion on both sides of the air intake such that the flap that we will cut right now will gently rest onto your lift thrust divider. So what you can do at this point is actually cut these two inner edges of your air intake. And then you can insert your air intake lift thrust divider once again. And you can tape the air intake flap down onto your lift thrust divider to ensure that it does not move. Your divider should now be able to open and close like a door. Next, cut out the duct piece from your template and fold along the dotted lines. The way I like to think about it is these two inner dotted lines, we're going to make mountain folds on them. And I call them mountain folds because they look like a mountain when you look at them from the side. So we're going to mountain fold the other one in the middle. And then the outer two flaps, we're going to create a valley fold. And I call this one a valley fold because if you look at it from the side, it looks like a valley or the letter V. So we're going to do the same thing to the other side. And these flaps are just to help us tape it down a lot more secured onto the body of our hovercraft. Now there's a little curvature, so I'm actually going to bend it a little to make it a little straighter. But once you have those folds, you can bend these down so that they're flat. And you want to orient your duct piece so that it's like a blocky upside down U. Or it could be a blocky N. Now, we're going to position the hole so that it is about 1 inch away from the ziplock edge. So you can use your ruler A to find the position for this. And so I'm going to place it right up against the ridge of our ziplock edge. And then you can position it. you want to make sure that the flaps of your duct piece is going to kind of be aligned with your lift thrust dividers tab. And you want to make sure that on the inside there's plenty of room in front of your lift thrust divider. Once you've positioned it where you want, which is about here, I'm going to go ahead and tape the flaps down. Another thing that you want to keep in mind with this hull, the duct piece, is that you want to make sure that it's as close to the lift thrust divider as possible. Now, once this is done, you should see that you should still be able to move your lift thrust divider up and down. And what we're going to do is we're going to lift our lift thrust divider so that it's perpendicular to our hull. And what that just means is that if you look on the inside edge, there's like a right angle. And now what you're going to do is you're going to angle your lift thrust divider slightly forward. So you should see that it's slanted like a forward slash on the inside. And you want to make it even on both sides. Once you have that, you can go ahead and use 2 pieces of tape on the inside to secure it. And I like to put half of the tape on the lift thrust divider and the other half into the inside of the hull. So this is one side done, and then we need to do the same on the other side. One other thing to note about this part is that you might notice that there's a gap where the lift thrust divider ends and where the body of your electric hovercraft begins. You kind of want to cover that with the tape as well, but if you don't, it shouldn't be too much of a problem. But if your students have trouble with airflow and having their electric hovercraft move, then that might be a good spot to check to see if any air is escaping. And once you tape that down, this is going to make sure that your air is properly being divided in half, and it also makes it so that your lift thrust divider doesn't move as much while your propeller is on. Then cut out the propeller stand and fold along the dotted lines. You should notice that this forms a hollow square, and we're going to use a small piece of tape to secure it closed. Next, position your propeller stand centered in front of the duct. You want to make sure that it's directly aligned with your duct piece as much as possible, and center it as much as possible as well. And you want this to be close enough to direct as much air into the duct, and so that the propeller sits comfortably inside the duct to protect the blades from coming into contact with anything. Again, you want to make sure that your propeller stand is centered, and once it is, we're going to go ahead and tape it. It's okay to use a little bit of extra tape in this section as well, just so that we ensure that our propeller stand isn't going to move too much. So I'm actually going to place a piece of tape right through the hollow square of our propeller stand. And it doesn't have to be too perfect, it just has to be as secure as possible. Next, grab a double-sided square and tape it down on top of your propeller stand. Then, take your 3.2 volt motor and attach the small propeller to it. Once you have done that, we can go ahead and remove the other film of our double-sided tape. And with the propeller facing the duct, we're going to attach the small propeller. Now for this part, when you're attaching the propeller, you really want to make sure that your propeller is as centered as possible. So it might mean that your propeller sits a little off-centered from your propeller stand, and that's fine, as long as your propeller itself is in the middle of your entire duct and your propeller stand. So in this case, I'm going to rotate it a little bit. You also want to make sure that your propeller is sitting a little bit inside the duct. So I can see mine is right at the edge of our duct. So I'm actually going to remove it and reattach it a little further inside. Now for this part, you do want to be careful so that you don't bend your propeller stand too much. Like this. And now I can see that my propeller is sitting a little too far to the right, so I'm going to rotate it to the left a little bit more. And once you're happy with the positioning of your propeller, you can go ahead and give it a little spin with your finger to make sure that it's not going to hit the walls. And once you've ensured that everything is fine, we can move on to the next step. Next, check to make sure that your battery pack is off. And we're going to attach the red wire of your motor to the black wire of your battery pack. And what I like to do is first twist them together, and then with a small piece of copper tape, you can secure them in place. Then you're going to attach the blue wire of your motor to the red wire of your battery pack. Once again, I'm going to twist them together, and with a small piece of copper tape, we're going to secure them. Then insert your 9-volt battery into your 9-volt battery holder. Again, you want to make sure that it's in the off position. Now that we have our electric hovercraft finished, let's go ahead and test it. To test it, hold the battery pack in one hand and make sure that your hovercraft is positioned sideways from you. And when you're ready, you can go ahead and turn it on with your thumb. Okay. So you may need to be very careful with this since it does move very fast, and you may also need to move along with it since the wires aren't very long. If your hovercraft is going backwards, you're going to want to switch the wires because you might have a different propeller than I do, and switching the wires will make sure that the air goes in the proper direction. Remind the students that this is why there is a testing step, and this is why they need to ensure that the propeller is going the correct way when you turn on the battery pack. Also, make sure you're only using the hovercraft on a smooth surface, not on a rough surface like carpet or concrete, because it may damage the air cushion and it may make it more difficult for the hovercraft to fly in the air. Now that we are finished testing our electric hovercraft, let's talk about how it works. Our electric hovercraft uses air from our propellers to blow air into our duct, which is split into mostly equal parts, and creates thrust. Part of the thrust goes into our air intake, and fills up our air cushion with a slight bit of air, which allows our hovercraft to lift slightly above the ground. This makes it easier for our hovercraft to be pushed with the other part of our thrust, and the other part of our thrust comes from the air that is blown behind our hovercraft, allowing our hovercraft to be pushed forward. Some questions that your students will be able to think about when working on your electric hovercraft are: how can we make the hovercraft fly forwards faster? What can we change about our hovercraft to make it better? Or what other supplies can we use to create our hovercraft?